Alright, so here we go, guys. We are learning today how to complete the square. But real quick, I wanted to identify with you all the different ways that we know how to factor. In my opinion, this is the one that probably you should build the best. It does require all this number sense. It does require all that strategic trial and error that we were talking about last time. But to me, that's probably your best bet to start off. The second one is going to involve square roots. I think that should be your second one that you build. The third one is quadratic formula. Actually, let me change that. The third one is this guy right here. This is factor by grouping. And you can put it in that box in your notes, okay? I think the fourth one should be, then you do quadratic formula. And the last one, only because it's a lot of work, but at the same time, it is a little bit daunting at times. Bless you, completing the square is your fifth form or method of factoring. But guys, if you get good at this, this will help you big time to set up equations. It'll help you set up equations to interpret transformations, the vertex, the stretch, the compression, all that good stuff. So this is a good tool for graphing. Alright, so let's review a little bit before we move on to completing the square for today. This right here is your trial and error, strategic trial and error, but this is the number sense method where you look at factors of C, which in this case is 6, which could be like 1, 6, or 2 and 3, and then you see what would the sum of those factors be. Okay? So the way I have this out, we put it like this. And you could see, depending on what you chose, what would they add to? If I chose 2 and 3, okay, I could get 5, or I could also get what? If I chose 2 and 3, I could get 5. If I chose 2 and 3, I could also get a 1. If I chose 1 and 6, I could get a 7. But if I chose 1 and 6, I could also get a 5. And here you see that we want the 7 that we have as our b term in the equation right there. So most likely 1 and 6 would be the factors for that one. Okay? So hence, that's what we have. In this case, x minus 1, x minus 6. If I distributed this out, aka FOILed this out, I would get that equation right there. Number sense, trial and error. Okay? Number 2 is to isolate the radical form. So way down here, if I isolate the radical form here, just put a little quick note. Remember the plus or the minus. So if I isolate this square root, how do I move that 1 over to the right side? What do I do? Subtract it. So I have 2x plus 3 is square rooted is equal to 5. Okay? So now, what would I do to both sides? Not by 2, but square both sides. So square both sides means I will raise this to the power of 2 so that, check this out if you don't know it already, this 2 will make the square root cancel and go away. So I get 2x plus 3 is equal to 25. Any questions so far? So if I subtract 3, divide by 2, I get x is equal to 11. And whenever I have these plus or minus, it's really, I meant this one, plus or minus, so when you have pieces that look like that. So if I take the square root of both sides, I would get a plus or minus 5. one is factor by grouping. So factor by grouping. This is when the a value is not equal to 1. For instance, right here, this a value is 3. Whoops. So this 3, what I'm wanting to do is the factoring by grouping method because that is not a 1. So I multiply, here we go, multiply a and c. So 3 times 4 is 12. And now I need to change this 8 to two numbers that will multiply to get 12 and will add to get 8. They will multiply to get 12 and they would add to get 8. What is that? 6 and 2. I just changed that 8 to what you see right now. Everything else around it stays the same. And now I will just pair these up and factor out their GCFs. Guys, what's the GCF for the first pair? 3x. And from that first pair, what are the scraps left over inside the parentheses? X plus 2. Good. What is the GCF from this second pair? 2. So I'll do plus 2. And what are the scraps that are left inside? X plus 2. If you do this correctly, these will be the same. And they will account for one of your two factors. What's outside of parentheses is the other answer. So those are your two factors. And yes, we would set equal to 0. All of these we would set equal to 0 and solve for x. Okay? Let's do the quadratic formula. So one person so far, one team has mentioned this. Nice job on that as far as our race that we started class with today. This equation you may or may not have been exposed to in Algebra 1. Okay? We do have to master it this year for sure. So a is the coefficient of the x squared term, which is 1. B is the coefficient of the x term, which is negative 7. And C is the constant that's all by itself, positive 12. Remember, this extends from, this equation that you already have had homework with extensively. The standard quadratic equation. Standard form. So let's go ahead and work it out. Here we go. Negative b plus or minus the square root of b squared. Notice that parentheses. This parentheses is mega important right here. B squared minus 4a and c. All over 2 times a. The radicand, which is this huge piece underneath the radical symbol, is what you want to solve for first. I always tell students, figure out what this product is right here. Don't let this negative throw you off. So just think of it as, what's negative 4 times 1 times a positive 12? What is that, guys? Negative 48. So I have 49, which is negative 7 squared. It's a positive. Minus 48. This would give me 1. I have 2 on the bottom, positive 7. So I have 7 plus or minus the square root of 1 all over 2. Which there's two answers right there. 7 plus the square root of 1 is 1. And then the other one is the minus 1. There's two versions. So this answer would give me 4. This answer would give me 3. So my factors would be x minus 4 and x minus 3. Because remember, they're the opposite signs of what you see over here. Because each factor is set equal to 0. Told you, there's a lot of methods of quadratic factoring. Last but not least, this one down here. I have a graph that is saying, look at this. The vertex is at 1, -4. So it's like way down here. Okay? And 1, -4 has two solutions, which are -1 and 3. Because I would set each of those factors equal to 0. So let me make sure I got this right. 1, -4. The solutions are at 3, which is way over here, and -1. Oh, that's why. 1, -4 is down here, guys. My bad on that. I don't know why I drew it over here in the third quadrant. So 3 and -1, it would look something like this. It's a nice rounded bottom at the end, and there's my quadratic. And these are inequalities. So there's a lot of shaded region. We're going to shade all the y's that are greater than or equal to this graph. Okay? Any questions? Guys, how many answers do I have for this bottom right-hand corner? 2. If this was equal to, right here, if there was an equal symbol right there, then it would be 2. But because it's a shaded region, how many do I have? Infinite solutions. Okay? We good? Yeah.
For the second one we did, how would you get that equation from the x squared plus x?
This one right here? The solving square roots?
Yeah.
Oh, all I did was move to get 5 and then square both sides.
I mean, how would you get 1 plus square root of x plus 3 plus 6?
How would I get it?
Yeah.
Oh, you're just given it.
Are you getting
Yeah, you're given it and you'd be asked to solve for x. Okay? Alright, so now the last one. The last one is completing the square. First of all, write it in form of ax squared plus bx is equal to a -c. All that means, guys, is get your x's all on one side. Get all of your x's on one side and move everything else to the right side. That's step 1. Step 2 is, this is the most important, this is the big piece that you have to memorize, is whatever your b term is, divided by 2 and square it. Bless you. Your b term right now is a +8. So if I'm going to do b divided by 2 squared, it's like 8 divided by 2, which is 4. Whoops. And square, which would give me 16. So I just added 16 to both sides because of this b over 2 squared. Now we're going to factor the perfect square trinomial. Look what we have. This is like that a plus 2ab plus b squared stuff. A squared plus 2ab plus b squared. This square rooted would give me x. 16 square rooted would give me 4. I'm going to borrow this first sign because they have to be positive. It is a squared. And I get -12 plus 16 will give me 4. Okay, guys. So, when I was talking about this plus and minus here, I meant it for this one right here. Okay? Because at this step that we are at right now, this step, we're going to square root both sides. So I will be left with x plus 4 on the left, because when I square root a square, they cancel. But don't mess up on the right. You've done this with absolute value. You have to have a positive and a negative version. So positive and a -4. Okay? So right now my running answer is x plus 4 4 is equal to a positive or a negative 4. So there's the positive one, and there's the negative one. Okay? So when I subtract 4, I'll get 0. When I subtract 4, I'll get negative 8. See you later. Did I do something wrong?
The square root of both sides.
Oh, my bad. So, my bad. Thank you. I was distracted. No worries. So this should have been what? 2. And it does change it for sure. Nice catch on that, guys. So this was a 2, a negative 2 here, positive and negative 2 right there. So what's my first answer over here? If when I move this 4 over. Negative 2, right? What's my answer over here? Negative 6. So x equals negative 2. If I asked you to write that as a factor, we know it looked like x plus 2. X equals negative 6. If I asked you to write it as a factor, it would be x plus 6. Questions over all this, because we're going to do more bonus point questions here in just a bit with practice. Any questions? So now, let's go back real quick to that question that we did where Aditi said you could use a quadratic formula. And now we know we can use other methods too. Okay? So if I'm wanting to factor this, let's say we use, we're going to start with completing the square first. That we use completing the square method. Here we go. The more exposure and practice you get, the better and faster you'll become. Here we go. The first step on completing the square is to get the x's all alone and move everything else to the right. Second step is to concentrate on this number right here and do this whole b over 2 squared business. So b is 4. So when I divide it by 2, I'll get 2. Squared would give me plus 4. So I'm going to put right here plus 4 to both sides. That's that second step. Guys, will this number always be positive? It will. Why? Because you're squaring. Okay? So now this is that perfect trinomial. The square root of x squared is x. The square root of this 4 is 2. It's raised to the power of 2. We're going to borrow that sign. And we're done. Is equal to 3. Next step, we're going to take the square root of both sides, which means this cancels that, square root will cancel that squared. Just remember, we have to put what there? Positive and a negative. It's very close to the quadratic formula. Very, very close. So I'm left with x plus 2 is equal to the plus and minus form of square root of 3. Okay? So now when I subtract this 2 to both sides, I'll get negative 2 plus or minus root 3, which, yes, we have two answers. We have negative 2 plus root 3, and we also have negative 2 minus root 3. Those are my answers. They're not clean integers. That's why we couldn't factor it cleanly when we were doing the race. Completing the square. Okay, one more example, or same example, one more method, and we will go to bonus points. So now if I did the same thing, but I did it with the quadratic formula, I have Hannah, what's A? 1. Chet, what's B? 4. Yep. Emeka, what's C? 1. So when I set this up, Ethan, how do I set it up using the quadratic formula?
Negative 4 plus or minus the square root of 4 squared minus 4, 1, 1
times 1, right?
Yeah.
Okay. Gabby, from there, what should I approach? So I'm going to approach this, but let's figure out what this equals. So Gabby, what's this?
16.
And what's that? So what do I have?
16
Is 12. Good. Zach, what would I do from here? Well, there is a plus and minus right now. Okay, I got you. Okay. So negative 4 plus square root of 12 over 2, and then negative 4 minus root 12 over 2. For sure. Yeah. Casey, where do I go from here? Because I want to simplify it as low as possible. Okay, you are not alone. A lot of people think that you could reduce those, but you can't because they're not in the same family per se. This 12 that looks like this, I can write it also like that. Means the same thing, the square root of 12. But the 2 is just written as 2 to the power of 1. Because they're not of the same fractional exponent, we can't necessarily cancel. And you're not alone. Everyone wants to try to cancel that 12 with the 2, but you can't. But what we can do, and you've done this in Algebra 1, hopefully you did it to a high level with practice. I want to reduce that. Okay, let me help you out. What is the number that belongs there that we don't have to write but is understood to exist there? 2. Okay, this is the same as that 2 right there. Now watch. This 2 means I can break this down into factors and pull them out in pairs. So 12 can break up as 2 and 6. 6 can break up as 2 and 3. These are the lowest prime numbers that I can go. So 12 is the same as that. Because 2 times 2 times 3 is 12. And this 2 means that you're going to bring it in parties of 2. So these couple of 2's are going to come out, because of that, as just 1, 2. And the 3 is left in there. For instance, let's say that we had 32. But we weren't taking the square root, we were taking the cubed root out. 32 is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. And if I'm taking it in a party of 3, that group is going to come out as a 2. Can this party come out? No. They're not a party of 3. You just keep waiting. You just stay where you're at. Okay? So 2 root 4 would be the simplification, or sorry, 2 cube root of 4 would be the simplification for that one. So all of that to understand roots, okay? Yes, we're going to practice with that even more, for sure, throughout the rest of the year. So the root 12 business can now change to this. 2 root 3. And you're probably asking, why did we just do that? Why did we do all that work? I know we can't reduce 12 and 2, but look at this. We can now reduce those 2's. And that 4. If you don't don't see that you can do that, please write it in your notes, because this is a common mistake. Quizzes, we have a quiz coming up. This piece right here, because it has the same denominator, can be written as this piece. And I'm not even kidding, guys. The math that I'm showing you in this unit, when you master it, calculus is significantly easier. The only reason why most of my calc students struggle, or most calc students across the nation pretty much, is because their Algebra 2 skills aren't on point. All these small subtleties, they don't have it cleared up. They think they know, but they don't. And then they refine it in calculus. When you refine it here, you have nothing but just calculus to learn when you get there. Okay? Calculus is very, very easy. It's a lot easier than what you think. But you have to refine your Algebra 2. Okay? This will reduce to what? Negative 2. Plus what? Square root of 3. So this answer is negative 2 plus root 3. Okay. What's the other answer? Negative 2 minus root 3. Those are both my x equals. Questions? I know it's a lot. Just want to make sure that we are getting all the practice before we go to group time, because I want to give your team the best chance at getting these points. Okay, so let's go ahead and begin.